Hello everyone, myself Hans. Today we are going to solve the problem of 2012 from complex integration. Here in the question, evaluate by counter integration and integral is given by 0 to 2 pi d theta upon 1 minus of 2a cos theta upon a square, and a square is less than 1. So let's solve the problem. Given integral is this is I is equal to 0 to 2 pi d theta upon 1 minus of 2a cos theta plus of a square, and let this is fz is equal to d theta upon 1 minus of 2a cos theta plus of a square, and we know that we know that z is equal to e to the power of I theta. Then we have to differentiate with respect to theta. This is dz is equal to I e to the power of I theta d theta, and again put the value of e to the power I theta. This is given by d theta is equal to I into z into d theta, and from here we have to find the value of d theta is given by dz upon iz, and we can also know that cos theta is equal to 1 by 2 z plus of 1 by z. Cos theta is equal to 1 by 2 z plus of 1 by 2. So we have to put here this is 1 upon, and we have to take this is close integral c, and here is d theta upon 1 minus of 2a cos theta plus of a square, and we have to put the value here. This is given by close integral c 1 upon of 1 minus of 2a, and we have to put the value of cos theta. This is given by 1 by 2. Once again, this is given by 1 by 2 into z plus of 1 by z, and here is plus of a square, and we can also put the value of d theta. This is given by dz upon iz, and further we have to solve. This is given by close integral c, and from here we have to cancel out the terms. 2 to 2 is cancelled out, and this is given by 1 upon of 1 minus of 1 minus of, once again we have to this is given by 1 minus of a, and this is z plus of 1 by z, and plus of a square and this is dz upon iz, and further we can also write this is 1 upon of I and close integral c, and z multiply with this function. This is given by 1 upon of z minus of az into z plus of 1 by z, and plus of a square z, and this is dz. And further we have to simplify the denominators. This is given by 1 upon of I and close integral c, and this is dz upon, from here we have to take z and a square z in one bracket. This is given by taking z common. This is 1 plus of a square, and From here we can also, once again, we have to take z minus of, here is minus of az, minus of az. Once again, we can simplify the terms first. This is, once again, this is z minus of az square, z minus of az square, and minus of a, multiplying a minus of az with z, that to that cancel, that is minus of a plus of a square z, a square z, and we have to take from here, minus is taking outside, this is minus is taking common from denominator, this is 1 upon of I, this is minus, and dz upon close integral c. When we have to take common minus, here is plus of az square, minus of az square is plus of az square, and plus minus of a is plus of a, and this is plus of a square z is minus of a square z, and here is plus of z is minus of z. And further we have to take in one bracket, this is given by, once again we have to take from here, this is, we have to take once again, we have to taking in one bracket, once again we have to solving here, this is given by az square plus of a and minus of a square z minus of z. So we have to take first, this is z square. When we have to take in one bracket, this is given by z, and az minus of 1, az minus of 1, and here we have to take common a, this is given by az minus of 1. Once again, this is we have to take minus here, and az square and z. First we have to take from here, we have to solving, this is given by az minus of 1 multiplying, this is minus of a square z and plus of a. This is given by z minus of a and az minus of a. This is the two factor. Here is the factor is minus of 1 upon I close integral c. This is given by dz upon z minus of a, and this is az minus of 1. And further we have to find the poles of the given integrand. Poles of integrand, that is denominator is taken to, this is denominator is taking equal to 0, so we have to find the poles. This is given by z minus of a is equal to 0 and az minus of 1 is equal to 0. This is given by z is equal to a, and from here is az is equal to 1 and this is z is equal to 1 by a. So here is z is equal to a and z is equal to 1 by a is the poles, and the poles lies here. This is given by a square is less than 1. So we have to the poles z is equal to a lies inside the closed circle, and further we have to find the residue at z is equal to a. This is given by residue at z is equal to a. This is given by limit z tends to a, and this is given by, once again, this is z minus of a, and this is fz, this is 1 upon of z minus of a, and this is az minus of 1, az minus of 1, and further we have to put, this is in place of z is equal to a, this part and this part is removed, so we have to put z is equal to a here. This is given by 1 upon of, in place of z we have to put a, this is given by a square minus of 1, once again az minus of 1, and here is the poles is z is equal to 1 by a. So we have to put here, this is given by, in place of simple poles, once again we have to put z is equal to a, this is a square minus of 1, this is the residue at z is equal to a, so we have to use Cauchy residue theorem. So we have to use Cauchy residue theorem. This is given by close integral c fz dz is equal to 2 pi I into sum of residue. Here summation r plus c is denotes sum of residue. So we have to write here, this is given by close integrals. So we have to put the given integral I, this is in a place of fz, this is 0 to 2 pi, and fz is d theta upon 1 minus of 2a cos theta plus of a square, and this is given by 2 pi I into, here is sum of residue is given by 1 upon a square minus of 1 is already present, and we have to find, this is 1 upon minus I, this is given by minus of, once again this is given by, we have to take minus common, once again this is given by minus 1 upon I into a square minus of 1, and from here this is I to I is cancelled out, and the remaining is here 2 pi upon a square minus of 1, minus 1 is missing once again. From here we can also write in the form of z is equal to 1 by a is written as z minus of 1 by a. So we have to write here, when we have to find simple poles, we can also write here, this is z minus of 1 by a, z minus of 1 by a, and then we have to put here, this is given by 1 upon of, in place of z this is putting a minus of 1 by a, this is given by a upon a square minus of 1, and we can also write, this is minus of a upon 1 minus of a square. We have to take a minus from denominator common, and so we have to put here, this is given by, so we have to put here the sum of residue is 2 pi I, and the sum of residue is given by here minus of 1 upon I, and the sum of residue is given by minus of a upon 1 minus of a square, and from here is I to I is cancelled out, and this is given by integral 0 to 2 pi d theta upon 1 minus of 2a cos theta plus of a square is equal to, this is given by minus minus is plus, this is 2 pi a upon 1 minus of a square. This is the required solution of the given problem. When we take here, this is az minus of 1, we get different answers, so we have to write here, this is az minus of 1 is equal to 0, so we have to write here az is equal to 1 and z is equal to 1 by a. So we have simply put this is z 1 by a is taken to left hand side, this is z minus of a is equal to 0. When we have to find z at z is equal to a, when putting z minus of 1 by a. Thank you class and thank you for watching. This is the required solution of the given problem.